Heat treatment of steels. The term heat treatment may be defined as the operation or combination of operations which involves heating and cooling of a metal or an alloy in the solid state for the purpose of obtaining certain desirable conditions or properties without change in chemical composition. So the purpose of heat treatment is to achieve many objectives. So we will see the objectives one by one. Heat treatment is used to increase the hardness of metals. Second one is to relieve the stresses set up in the material after hot working or cold working process, to improve machinability, to soften the metal, to modify the structure of the material to improve its electrical and magnetic properties, to change the grain size, to increase the quality of the metal, to provide better resistance to heat, corrosion and wear. The following are the various heat treatment processes normally employed in engineering practice. First one is normalizing. The objective of the normalizing are to refine the grain structure of the steel to improve the machinability, tensile strength and structure of the weld. Second objective is to remove strains caused by cold working processes like hammering, rolling, bending, etc., which makes the metal brittle and unreliable. The third objective is to remove dislocation caused in the internal structure of the steel due to hot working. Another objective is to improve certain mechanical and electrical properties. The process of normalizing, it consists of heating the steel from 30 to 50 degrees Celsius above its upper critical temperature, or there is something called Ekme line. It is held at this temperature for about 15 minutes and then allowed to cool down in still air. This process provides a homogeneous structure consisting of ferrite and perlite for hypoelectric steels and perlite and cementite for hyperelectric steels. The homogeneous structure provides a higher yield point, ultimate tensile strength and impact strength with the lower ductility to steels. The process of normalizing is frequently applied to castings and forgings, etc. The alloy steels may also be normalized, but they should be held for 2 hours at a specific temperature and then cooled in the furnace. The second heat treatment process is called annealing. The main objective of annealing are to soften the steel so that it may be easily machined or cold worked. The second objective is to refine the grain size and structure to improve the mechanical properties like strength and ductility. The third objective is to relieve internal stresses which may have been caused by hot working or cold working or by unequal contraction in casting. The fourth objective is to alter electrical, magnetic or other physical properties. So annealing is also used to remove gases trapped in metal during initial casting. The annealing process can be classified into 2 types. The first one is called full annealing. The purpose of full annealing is to soften the metal to refine the grain structure, to relieve the stresses and to remove trapped gases in the metal. The process consists heating the steel from 30 to 50 degrees Celsius above the upper critical temperature for hypoelectric steels and by the same temperature above the lower critical temperature, that is 723 degrees Celsius for hyperelectric steels. Then holding it at this temperature for some time to enable the internal changes to take place. The time is allowed is approximately 3 to 4 minutes for each millimeter of thickness of the largest section. Then the metal is cooled slowly in the furnace. The rate of cooling varies from 30 to 200 degrees Celsius per hour depending upon the composition of the steel. In order to avoid decarburization of the steel during annealing, the steel is packed in a cast iron box containing a mixture of cast iron, borings, charcoal, lime, sand and ground mica. The box along with its contents is allowed to cool slowly in the furnace after proper heating has been completed. The second type of annealing is called process annealing. It is used for relieving the internal stresses previously set up in the metal and for increasing the machinability of the steel. This process, steel is heated to a temperature below or close to the lower critical temperature, held at this temperature for some time and then cooled slowly. This causes complete recrystallization in steels which have been severely cold worked and a new grain structure is formed. This process of annealing is commonly used in sheet and wire industries. The third type of heat treatment is periodizing. It is another form of annealing in which cementite in the granular form is produced in the structure of the steel. This is usually applied to high carbon steel which are difficult to machine. This operation consists of heating the steel to a temperature slightly above the lower critical temperature, that is 730 to 770 degrees Celsius. It is held at this temperature for some time and then cooled slowly to a temperature of 600 degrees Celsius. The rate of cooling is from 25 to 30 degrees Celsius per hour. Periodizing improves machinability of steels, but it lowers the hardness and tensile strength. These steels have better elongation properties than normally annealed steels. The fourth type of heat treatment is called hardening. The main objective of hardenings are to increase the hardness of the metal so that it can resist wear. The second objective is to enable it to cut other metals, that is, to make it suitable for cutting tools. The process of hardening consists of heating the metal to a temperature from 30 to 50 degrees Celsius above the upper critical point for hypoelectric steels and by the same temperature above the lower critical point for hyperelectric steels. Then keeping the metal at this temperature for considerable time depending upon its thickness. Then quenching, that is cooling suddenly in a suitable cooling medium like water, oil or brine. The low carbon steels cannot be hardened appreciably because of the presence of ferrite, which is soft and it will not change by the heat treatment. As the carbon content goes on increasing, the possible obtainable hardness also increases. The next heat treatment process is called tempering. So in this process, the steel is hardened by rapid quenching, and because of that it becomes very hard and brittle. And steel also contains internal stresses which are severe and unequally distributed to cause cracks and even rupture of the hardened steel. So tempering is done for following reasons: to reduce the brittleness of the hardened steel and thereby it increases ductility. The second objective is to improve or to remove the internal stresses caused by rapid cooling and to make the steel tough to resist shock and fatigue. The tempering process consists of reheating the hardened steel to some temperature below the lower critical temperature, followed by any desired rate of cooling. The exact tempering temperature depends upon the purpose for which the article or the tool is to be used. The last type of heat treatment process is called surface hardening or case hardening. In many engineering applications, we need the steel to be used should have a hardened surface to resist wear and tear. But at the same time, it should have a soft and tough interior or core so that it can able to absorb any shock load. So this is achieved by hardening the surface layer of the article while the rest of it is left as such. This type of treatment is applied to gears, ball bearings, railway wheels, etc. Different types of surface hardening processes are carburizing, cyaniding, nitriding, induction hardening and flame hardening.